The next demo, we are going to show you how to do programmable edge with NF1208 digital I/O module. We know that NF1208 is industry's first PXI 3U size 100 MHz pin electronics digital I/O module. It has support of steel-based compatible events for each of the 4 edges within a cycle. So all the 4 edges, D0, D1, D2, D3, are software programmable with 39.06 picosecond resolution. The picture below shows an example of programmable edges within a vector clock cycle. Now let's move to the LabVIEW software interface to see the actual demo. In this demo, we are going to show you the capability of NF1208 digital I/O module to generate digital patterns with programmable edge. In this particular case, we will show you the programmable rising edge. In front of you, the LabVIEW program is already running. In this case, we are generating a digital vector with frequency of 25 MHz. And the vector data being generated is 10101, and it's generating the data continuously. If we go back to the screen of the timing formatter where we program the rising edge of the digital pattern, we can see currently all 4 channels, channel 0, channel 1, channel 2, and channel 3, they are generating frequencies with the rising edge at 5 nanosecond precision. Now, let's look at the oscilloscope string output. You can see that we have captured 2 patterns, and both of the patterns, the rising edge, are aligned. The oscilloscope string now shows 2 digital patterns, the channel 2 and the channel 3 of the digital I/O module, being generated at the same rising edge. In fact, both signals are rising at 5 nanoseconds within the cycle. Now I'm going to change the rising edge position of channel 3, which is the second curve as shown on the oscilloscope. So I clear the selection for channel 0, channel 1, channel 2, and leave channel 3 checked. I select moving edge. I check this box to indicate that I want to move the rising edge position of channel 3. Previously, the rising edge position of channel 3 is 5 nanoseconds. Now I move it to 7 nanoseconds. I click Add. Now let's look at the oscilloscope string. Now if we program the rising edge position of channel 3 of the digital I/O module to be 7 nanoseconds, you can see that on the oscilloscope string, the blue color curve, which represents channel 3 of the digital I/O module, moving to the right by 2 nanoseconds. This shows the capability of the digital I/O module to be able to program the rising edge position of the digital pattern. In fact, we are able to program 4 edges within a cycle for any digital pattern. Now let's move the rising edge of channel 3 digital pattern further to the next position. Let's say we want to try the position of 30 nanoseconds. Once I key in 30, I click Add. Now if you look at the oscilloscope string again, you will see that the digital pattern curve for channel 3 vector data is moving further to the right. Once I program the software, you can see the blue color curve moving further to the right. And in fact, measurement on the oscilloscope will confirm that the delta time difference between the yellow color curve and the blue color curve is 8 nanoseconds. This showcases the capability of the I/O module in terms of its flexible edge programming.